Hi, in this one we discuss LeetCode problem 1937, maximum number of points with cost. So you are given an m cross n integer matrix points. Starting with 0 points, you want to maximize the number of points you can get from the matrix. To gain points, you must pick one cell in each row. Picking the cell at coordinates r, c will add points r, c to your score. Okay. So however, you will lose point if you pick a cell too far from the cell that you picked in the previous row. For every row, two adjacent rows r, and r plus 1, picking cells at coordinate r, c1 and r plus 1, c2 will subtract absolute value of c1 minus c2 from your score. Return the maximum number of points you can achieve. Okay. So here actually for this example 1, so what is the matrix I have given? 1 2 3 1 5 1 3 1 1. Okay, so what is the, suppose for this matrix suppose I choose initially from first row I choose these two, so initially score is 0, so I will actually, this point will contribute to there is no previous row, so that's why there is no chances of any point loss, right? So suppose from row 2 I choose 5, so this will actually contribute 5, and the previous row from the previous row I have choose this 2, and what is the column was 1. Similarly for this also, row 1 row 2 also we are choosing column number 2, so that's why no chances of lose, because 0 minus 0 it will contribute 0. Suppose from row 3 I choose 3. Okay, so this 3 will contribute into the score, and what is the actually value I will actually lose. This column was previous row column was 1, and for this column was 0, so 1 minus 0. So this is ultimately 0 plus 2 plus 5 plus 0 plus 3 minus 1, right? So this is actually 7 plus 10 minus 1 9, right? Zero plus 2 5 to 7 9, right? For this path, like for 2 to 5 to 3, the score is actually 3, right? So if I come from 3 to 5 to 3, okay, 3 to 5, then 5 to 3, then for 3 it will contribute 3, and there is no previous row, so there is no any chance of loss the point, right? Now from 5 actually we are choosing 5, so it is to contribute add 5, and the column difference is absolute value of, sorry, this is the difference, so this will actually minus of 0 1 2 2 minus 1, right? This is absolute value for, so whenever choosing 3, so it will go add 3 into the score, and what is the point I actually lose? This 1 minus 0, so this will 8 plus 8 minus 1 plus 3 minus 1, so this is actually 11 minus 2 is equal to 9. For this path also the score is 9, so in this actually you can check all the path and order the maximum score, actually this will be the answer. So what is the brute force approach here actually? So for any matrix, when I'm choosing anything, okay, suppose this actually suppose x y z, and this is actually a b c. So whenever we are trying to come to this cell like I comma j, so what is the possible actually from where actually I can actually come to this cell? Like I can come from x to a, then I can come from y to a, then z to a, right, to come to this a. Okay, this actually our score if we come to this. So how actually choose? Like I will choose whatever the value at the score at the x plus this a minus this, actually subtract the, I'll choose, I will lose any value or not by the difference of the column. So both the column actually same, so suppose c1 minus c2 is c1 minus c1, both are same, so that's actually same. Okay, this is for this path x to a. Suppose for y to a, So I'll choose score y plus a minus c2 minus c1, right? So now I'm choosing from z to a, so this will be score of z plus a minus c3 minus c1, got it? And this is actually column c1 c2 c3, suppose. Okay, so this way actually I will get this all possible score if we come to this index this a, right? So in this actually, what is the time of of this? Like I will get the maximum score for each position, and ultimately at the last row I will find out what is the maximum score actually I can reach here, because ultimately I have to reach the last row, because from each row I have to choose one cell, and at the end also I have to choose one cell. So I will choose whatever the ultimate maximum value, I will choose that cell actually, that part actually, right? So what will the time to do this? Like for each row I will traverse this, right? For each row I will come to this. So time actually first of all r cross, then for each position, like here actually for a I am actually choosing. So for each position actually I am choosing. So how many actually position are there for each row? Number of column, like for a b c, here actually column actually 3, that's why 3 actually position are possible. So for each position I am actually checking the previous score, and I will try to take the maximum score from out of all of this. So this is actually for each column, like for each position I am actually traversing the previous column again. So that's why the time total of r cross c square, this is ultimately cross the actually time limit exit, right? You understood the brute force approach, right? Here actually how can actually optimize this? So one observation you can check, like for each position, suppose this is the position, so I'll try to come to this position. Okay, so this is actually I minus 1, and this is actually I, and suppose this is I comma j. Okay, right? So this is I minus 1th row, this is for ith row and jth column. I try to come to this cell. Okay, so from each row previously what we are doing, we are checking for each position I am actually traversing the previous previous row score, and I will try to take the maximum value if we come to, and I want to reach this cell, right? So what actually ultimately we are doing, like ultimately we try to come to this dp of I comma j, right? And I try to take the maximum value, right? So for any index, like any index means any column I can actually come. So previous row is I minus 1, and I try to come from k. Suppose kth column I want to come to reach jth column, right? So what is the actual score? This is actually score from the previous row and the kth column, right? Now, and what is the actual contribute? Point of I comma j, right? Point of I comma j. And what is the actual I will lose? Absolute value of k minus j, right? This is I will lose. So suppose actually two cases are possible, when k is equal to greater than j, and another case is when k less than j. So case 1, suppose when k is greater than j. Okay, so what will be the expression look like? dp of I comma j will be dp of I comma I minus 1 comma k. We're trying to come from column k, plus it will contribute point I comma j, right, minus k minus j, right? Because k is greater than j, so k minus j it will ultimately. So this will be dp of I minus 1 comma k minus k plus point I comma j plus j. So I am just pairing up that related column. Like actually you can actually check, like this is dp I minus 1 comma k minus k, and for current I comma j we are adding plus j, right? So this is when we are coming from k greater than j. So what does it mean, k greater than j? Suppose this actually j and k, we are saying that k is greater than j. So k is greater than j means this actually like coming from right actually, right? That time actually k will be greater than j. When you are coming from right column to left side, that time actually it will actually column k will be greater than j, right? Like from 3 to 1, 3 to 1. That time this is still k and this is still our j. Got it? And another case is when k is less than j. So that time dp of I comma j will be, expression will look like dp of I minus 1 comma k plus point I comma j, okay, minus j minus k, right? So it will be look like dp of I minus 1 comma k plus k, then point of I comma j minus j, right? So whenever trying to come to from left to right, that time we will try to thus expression will look like this. So previously what we are doing, we actually don't actually do anything that left from where we are coming from, left or right, anything. We are just iterating the each column. Each column means the previous row's column, and we are trying to try to reach to the I comma j. That time I know that absolute value I will track. I do not have to check that this is I am coming from left to right or right to left. Okay, so if I optimize this, how actually optimize? If I just store the maximum value from left, like 0 to I, and maximum value from column minus 1 to I, that time I actually check that, okay, if I come to right side of this column, if this current cell, that time what is the maximum score I can actually can take. And we are trying to come to left to this index, this cell I comma j, that time I will store in the left column, left array, that what is the actually maximum score actually I can actually take if I try to come from left to this I comma j. And this right array actually store what is the maximum score actually I can actually take, right? So I will take two array, left and right. In this actually I will store the pre-calculated this value, this two value. This is I will store in the this is for k greater than j, so this will store in the right array, and this I will store in the left array, this expression value maximum. So for particular each index I will store the maximum left score actually I can see, and in the left array, and for the right array I will store in the ith index that what is the maximum score I can take from if I come from the right to this index. Got it? And then I will try to take what is the maximum value, like what is the maximum value from the left, like left of left of j. When you're trying to come to I comma j with from left, then I already know the left j value plus point of I comma j, and trying to come from left, okay, then the minus j, right? This is one possible when you're trying to come from left. And what is the right of j plus point of I comma j plus j. Then I will try to take the maximum value of out of this. If we come from left, what is the maximum value? And we come from right, what is the maximum value? That will be the value of dp of I comma j, right? So just go to actually code actually. So it's like taken first of all find out how many row are there and how many column are there. Okay, so if row is equal to 0 means return 0, there is I don't have to check anything. Now we have taken a dp vector or 2d dp vector, where actually row cross column, okay, r cross column. Now first row, there is no case of coming from previous row, right? This is actually first row, so there is no option to come from whichever column I will come. There is no selection of path, right? So that time for first row I am just initialize with the value of the point, like the input matrix. So dp of 0 I, it will be equal to points 0 comma I. Got it? Now for each row actually I am traversing. For int I is equal to 1, I less than r, I plus plus. So remaining row I am just traversing, right? So I have taken two vector, one for left, one for right. Okay. So for left, actually you can check dp of I comma minus of 0. So this is actually the just the previous value. Okay. For k is equal to 1, k less than c, what you are doing, what you will store? When you are coming from left, this is for left situation, k less than j. That time what will store? Whatever the dp I comma I minus 1 comma k value I have plus k, right? So what is the dp value I have plus k? So you can check whatever the maximum value I have seen till now, k minus 1 it will store, and dp of current value, dp of I minus 1 comma k plus k, what is the maximum value I will store in the left of k. So this will store from 0 to I, what is the maximum score I can take, right? And for right array, I am storing from right like I to column minus 1. So that's why right of column minus 1 it will be store dp of I minus 1 comma column minus 1, and I have stored it minus c minus of c minus 1. Why? You will check like when this is for right, when I coming from right to left, that time what will be I minus k. So here k is the c minus 1. So that's why I am just subtracting it minus c minus 1. Got it? Sorry. So this is actually k minus 1. K minus 1 means c minus 1, sorry, minus of c minus 1. Got it? In this section I have initialized the rightmost, and then I am just traversing from right to left. K is equal to c minus 2, k greater than 0, k minus minus. Okay, so right of k it will be maximum value of right of k plus 1. So what is the previous what is the maximum score I have seen here actually? So what will be the maximum value for this I have seen till now, and if I try to take this, then what will be the score? Whatever the maximum value I will actually take this. So dp of I minus 1 comma k minus k, this is actually expressed, right? dp of I minus 1 comma k minus k, and in this actually I have stored the like c minus 1 to I, store the maximum right score actually I can take from right if I come, right? So for each column I actually choose. So for each column means j0 0 j less than c. So each column means for each position I will check what is the maximum score I can take if I come to this index I comma j, right? Okay, so whatever the score I will contribute points of I comma j, this I will contribute always. And what are the maximum value of left or right? If I come from left, what is the maximum value, and if I come from right, what is the right maximum value? I will take this, because this is actually constant points I comma j. Anyway, it will actually add this score, right? And what will actually other things like this will actually handled by this left of j minus j. Got it? Left of j minus j. Why? You can check. This is the situation when I am coming from left to right. Left to right means points of I comma j minus j. So this is actually constant. Both in both situations I will actually add this, but this actually plus j and this actually minus j. Got it? One observation. So when you are coming from left, I will just know the left of I minus j, and for this I know the right of j plus j. Got it? Then what is the maximum value? I will actually choose this, because points I comma j always actually constant. There's a points I comma j I have actually taken as a constant, and what is the maximum value? Left of j minus j. I have actually shown you that when I am coming from left to right, I actually subtract the minus j, and when coming from right to left, I will add this plus j. Okay, then whatever the maximum value I will choose store into the dp of I comma j. In this way, I have actually calculated the maximum score I can actually take for each position. Okay, then ultimately on which position I actually store the final score. So if I supposed to have reached to this path in this cell, then I can reach to this cell, then I can actually choose to this cell. Okay, then at the end actually this row actually store the ultimate maximum score I can take. I can actually reach here actually, maximum I can actually reach. So that's why for the last row I will check for each position, like I can take actually any value. So that's why I will choose any position that I can choose, right? So that's why I will choose the which position actually give the maximum value, maximum score. That's why I am traversing I comma 0, I equal to 0 and I less than C. And what is the maximum answer? Initial answer is 0 and answer of dp r minus 1, the last row and the current column I. What is the score of this? And ultimately store into the answer and the end return answer. Alright. So what is time velocity to this? So here is a for loop. The time velocity here actually r, right? R into. So the for r this is actually r. This is for column, right? Sorry, this is for column. Time velocity is column, right? For each column I have to traversing. Okay. So for this for loop I have actually iterating r times. Okay. So for each times I have actually calling this, I am actually iterating a for loop again C. So r into C to calculate the left maximum score, and for right also I am iterating this. So this is also for C times. Okay. So that's why I am adding actually C, and here also I am traversing for each position I am calculating the maximum score. So this is also C, and here also there are for loop. So this is outer for loop. So this is also traversing C times. So the ultimate time velocity is big of C plus big of R plus C, C plus C 3 times actually I am calling, one for left, one for right, and one for the actual score. And at the end I am iterating the last row. So that's why the time velocity is big of C. So ultimately total time velocity will be R cross C. Got it? This is actually the time velocity. Understood, right? Thank you.